Welcome everybody to our SoftTree webinar series. My name is Jeremy Gonzalez and today I am joined with Jack Rymack. Today we're going to be presenting to you on easy road design with RoadEng. So to get started, a few housekeeping items. As always with all of our webinars, the participants are muted. If you have any questions, please engage us through the GoToWebinar questions panel. Sometime after the presentation, we will be putting this up on our YouTube page so that you can view it again. So let's get started. Some of the concepts that Jack's going to be covering today, we're going to start off in our terrain module, and within there he's going to import the survey data. He's already set up a specification, and with our specifications you can create it once and use it again. Also within the specifications you can set it up to automatically connect point codes to create features. After that, Jack's going to be creating a digital terrain model, and this is really the base for once he goes into the location module to design the road. It's quick and easy to create contours. He can also check the 3D window for any bad points and correct them there. Then Jack will be moving into the location module where he will be setting up a template which will allow him to view a road cross-section. Within the template area, he can create different variables for the road width, any of the slopes, after which Jack will be starting the horizontal alignment where you can work with curves, and he will be using the AASHTO standard for this webinar. Then he'll be creating the vertical alignment and adding curves, and while he's doing that, he'll also be balancing his earthworks. Then Jack will show us a drive-through of the road that he's designed, and finally he will be doing a multi-plot output. So with that said, I'm going to turn the presentation over to Jack now, who's going to show you how to design a road.
Thanks, Jeremy. Remember, if you do have any questions, there is a chat panel that you can ask questions. I'm going to start by importing my data. I've already created an import specification for a import file that I'm going to use. The import spec is called North County Road. If I look at it, you'll see the structure is northing is in the first column, easting is in the second column, elevations in the third column, is a code in the fourth column. And here's some of your codes, and some of them I've connected up into line work, like this code right here is connected up into line work. It's a polyline, it's connected, it's a break line, and there's the color, and it's solid line type. And I also have a center line code that I've connected, and there's others in here too. I'm not going to belabor that. Let's just go to import the file. Once you've created your import spec, which I've done, you save as default. Press OK. Open up my file. Use my import spec. Press OK again. Continue. There's my file. All these break lines have been set up for me automatically by the software. Let's go in, and next concept we're going to cover is generating a tin and contours. Top part of the dialog box is your triangles. The bottom part of your dialog box is the contours. I'm going to increase the length of the triangles to be around 400 feet. By the way, for our Canadian friends, this is an Imperial English file. Everything I'm going to be talking about is in feet and inches and miles. So be patient. You can design in metric. It's just that this particular design happens to be in Imperial. I'm going to set my contour interval to 2 feet for minor contours, 10 feet for major contours. There's the range, 1380 to 1460. There's my contours. Look at a 3D view of this really quickly. We'll come back to the 3D window again when I do a drive-through. But yeah, it looks like an existing road that I'm going to redesign. Change the design speed on that road. Minimize that. Oh, shoot. Minimize this. Select the point where I want to start my design. Right around this point here. Maybe a little bit forward. Save my design. Go to the location design module. Okay, next I want to import my terrain surface. Go to the location where I saved that file. Open up that file. Current point. Start that current point which I selected in the terrain. Do you remember if I selected that point all the way at the beginning of that road? Start there, finish there. Retrieve a screen layout. Okay, so the next concept I'm going to talk about before I actually do it is screen layouts. Screen layouts are these little files that set up your screen for certain functions, certain things that you want to do. I want to start with horizontal alignment. So I'm setting up my screen layout for horizontal alignment. Next concept I want to talk about before I actually start designing is templates. I'm going to get a set of templates that are a rural paved road. In this case, it doesn't have to be a rural paved road. It could be a gravel road. It could be a rail. It could be an urban curb and gutter with sidewalks. I'm going to open up a civil English road. Turn off some of these labels. Don't need to see labels all over the place. There, looks better. Talk a little bit about the template and its components. Every template is made up of a number of components. This template happens to have 6 components: a road left, a road right, a ditch left, a ditch right, a cut fill slope left, cut fill slope right. And you can change all of these, change the parameters for any of these components: widths, depths, slopes. Same with the ditches. And change the slopes and the depths and the ditch widths. And the final cut fill slopes, you can also change the slopes and whether they're included or not. Okay, so every template is made up of a number of components. Before I leave this area, I'm going to talk a little bit about how you can set up your road class specifications. This happens to be a 40 mile per hour road. You can change all of these driver limitations: reaction time, eye height, object height, radius, K value, max K, min K value and min K sag crest, deceleration, acceleration, max grade, min grade, max super. And then we also have super elevation tables built into the software. Your super elevation tables can be modified by you if you want. All they are is simple lookup tables. You across the top is your design speed. The first column is radius. And all the software does is, for instance, for a 40 mile per hour road and a radius of 600, the super will be 6%, in this case 0.059. For a 40 mile per hour at 700 radius, it'll be 5.7%, so on and so forth. You guys get the idea. Same idea with all of our tables. We have max side friction tables. Again, across the top is your design speed, and then it just simply looks up your max side friction for different design speeds. Transition lengths. So these are important for figuring out where your super, how long your super is going to, the length of your super. For instance, for a 40 mile per hour road and a 600 foot radius, we're going to have a 200 foot transition from no super to full super. Same idea with all these others. 45 mile per hour road, 700 foot radius. We'll have a 225 foot transition from no super to full super. That's all I'm going to say about these tables. You guys can modify those tables. They're just simple text tables. If they are not exactly for your standards for your state, please open them up in Notepad or in Excel and modify them. We can help you with how to modify these. I'm going to start designing a horizontal alignment. Left click anywhere from the start. I'm going to go towards the west. Left click again, going north. Left click again to tie it down, adding another PI or IP. Left click again, adding in the final IP or PI. Use these buttons in the horizontal curve panel to jump from PI to PI. I want to jump to the second one, which I'm at, and get my default curve, which I'm going to use as a 40 mile per hour. It automatically puts the radius in based on those AASHTO tables, and it's automatically going to use my table here. 200 foot radius, 200 foot transition is what it's going to use. And where does the transition occur from no super to full super? It's 0.667. So 2/3 of the transition will occur outside of the curve. 1/3 of the transition will occur inside of the curve. And the super is 6%. Just going to pull back a bit more just so I can fit that curve. Apply. Set that as my default. Oh, wait a moment. I gotta change it back. Set that as my default. Apply. Jump forward. Get my default. Apply. So I got two curves at 40 miles per hour. And the transition is going to be 200 feet long with 6% super, and 2/3 of that super is going to occur outside of the curve, and 1/3 is going to occur inside of the curve. Okay. Next concept is going back to the concept of screen layouts. Retrieve a screen layout for vertical alignment. I'm going to use training profile. Next concept I want to cover is vertical alignment and vertical curves. Before I do that, I'm going to widen out my road a little bit, or my surface a little bit, just because I can. In the location design module, you can add extra ground. I seem to be falling off the edge here, so I'm going to just add a little bit extra ground. There. So now I'm back having a lot of ground underneath me. And I'm also going to change, in that same dialog box, I seem to have changed my start station. I'm going to put it back at 0. And then all you do is simply just left click anywhere to the right of that first IP, or sorry, left click anywhere to the right of that first IP, left click again to tie it down. Software will automatically put a label on there. You can see some a graph down here, a diagram, it's a mass haul diagram. Right now we're endlessly cutting. If I pull my alignment up a bit above ground a little bit more, you'll start to see other colors like green. If I pulled it up a bit more, you would see colors like yellow. And if I pulled it up quite a bit, you would see colors like blue. There's a little bit of blue right here. What do those colors mean? Green is free haul. I can change my free haul distance, change my overhaul distance. Yellow is overhaul. Change my overhaul distance to 2,000. And borrow is blue. Waste is red. Pull that back down. Try to balance that a little bit better. Right now I'm balanced quite nicely within that section of road. Add some more IPs. Left, left, getting balanced quite nicely. Left, left. Just continue in that fashion. I'm not going to keep on repeating myself. I think you guys got the idea. I don't know if there's any questions, but let me just quickly check the panel. No, it doesn't. Oh, wait a moment. Oh, there is a couple of questions. What is the blue line? It does not appear to come from points. Terrain. Oh, the blue line in terrain. Let me just show you that. This blue line right here. The blue line is actually called EBL1, Edge of Bituminous 1. Sorry, that's not the group blue line. The blue line is actually called Edge of Flow Line 1. So there's an actual flow line that I've actually created in my setup, module setup. I've created a connection for edge of flow line, and it should be up here somewhere. There's my edge of bituminous lines, and my edge of flow line should be down here somewhere. There's my edge of flow line. Yeah, there they are. So those are the features that we also had connected. If you create this specification, as Jeremy said at the beginning, if you create this specification once, then you should be good through all of your designs, because your specification shouldn't change very often. Does that answer your question? All right, so I'm just going to continue on designing. Left click, and final design point all the way. I forgot to mention that we do, the software does automatically put a grade label on your design. Let me put in my vertical curves now before I actually forget to do them. Jump back using these buttons here all the way to the second IP. Get my default, apply, set that as my new default, 40 mile per hour. It will actually give me a K value of 52 and a length of 64.9 and a site stopping distance, which you can change, of 306.2. It's going to calculate the site stopping distance based on those specs that I had here. Reaction time, eye height, and object height will all be calculated by the software, calculate the site stopping distance, and deceleration and acceleration. Set that as my default. Jump forward. Get my default. I'll fix some of these borrow problems once I put in my rest of my curves. I'm just going to go quiet here for a second, just finish this off. Okay, go back and then just fix some of these borrow problems. First of all, I have one here. Bounce it off quite easily. And then I got one over here. A couple of areas over here. Pull that down a bit more. Pull this down a bit more. There, pretty well balanced. Green and yellow everywhere, which I like to see. A little bit of blue here. Pull that up. I got a little bit of too much waste now, so I'm going to pull it back up. There. Okay, before I go on to output, I am going to change one more item. Change my units. The units for our friends down to the south, the Americans, like to see their units in this format. Canadians and other people in the rest of the world like to see their units in this format. I'm going to stick to this one because this is an imperial design. Before I go into output, I'm going to do a drive-through. Show you how to drive through this road. Get my 3D window. Get my little car. Click on my car, which is up here. Drive through flyby. Play. Move this out of the way. It's almost 60 miles per hour. You can increase the rate here if you want to. Decrease the rate. End of the design. You can reverse it if you want to go in the other direction. I think I'll just stop here. Exit. That's good enough. I think you guys get the idea. It's a nice little feature to actually showcase your design and demonstrate it for some of your other superiors once you've done the design. Last thing I'd like to move on to is output. I just want to make sure that I get all the questions. Yeah, there's a whole bunch of questions. Can you see the horizontal projection plan and cross-section full cut, full fill? Yeah, you can see the horizontal projection of full cut and full fill if you want to in the plan window. Let me quickly show you that. I'm just going to get rid of this window. Go to my plan window. Maximize that. So you can see the slope stakes here. That's your cut and fill line. You actually can see them quite nicely in that previous drive-through that I showed you. If you're going through cut, you can actually see the cut. You can actually see your vehicle going below the ground. It's actually a nice little feature to actually see the cut and fill. If you want to see more than just simple slope stakes, then you're going to have to create a feature that it's a little bit beyond this demonstration. You're going to have to create a cut and fill feature that actually shows these slope stakes as different colors for cut and fill. I can do that for you outside of this demonstration if you want. I will leave that question of the system requirements for the program for Jeremy if he wants to chime in.
Sure. So the system requirements, they're quite low. We would recommend that you have 4 gigs of RAM, about 1 gigabyte of hard drive space. Onboard graphics card would be more than enough to run it. The more you work with LiDAR, the higher your, if you want to import a lot of LiDAR, the better specifications you need, but definitely the minimum does work.
Okay, I'm back and I'm going to do multiplot output sheets. Okay, so I am going to get my multiplot sheet, minimize some of these other windows, get rid of some of those other windows, retrieve a screen layout for output sheets or a book layout for output sheets. So this one has a bunch of different windows. The main ones are sectioned. So the way that our software is laid out now is it's laid out in book format with chapters and pages, and you can add chapters for any type of windows that you want to. If you don't want to see the plan and profile together, like most people like to see the plan and profile one above each other, and then they like to see sections separately. The section window has mass information down at the bottom. You can put the mass information in the plan profile window also, which I do have. It's right over here to the right. And here's all my pages. My pages are set up for my section window showing 100-foot cross sections. Bottom up. You can change it top down if you prefer, just by going in here, layout, turn off bottom up. If you want to see tighter cross sections, you can go in here and just change this to, for instance, to 50. So if you want to see cross sections every 50 feet, you can. That will give you a lot more pages. All the way to 21, and then we start with our profiles, page 22, page 23, page 24, 25, 26. And the software will give you the page numbers. It also put in a legend, horizontal curve geometry, vertical curve geometry. So you'll only see information in the panels, in all the data windows here, whether it's a volume data window for information that you see on that page. You won't see, for instance, cut and fill and mass haul for every single, for the whole design when you're in one page. What you see on page 2 is all the information for page 2 and not the information for page 3, page 4, page 5. So on and so forth. So that's a nice little thing where you can also only see the vertical curves for the page that you're looking on, the horizontal curves, the page you're looking on, the volume for the page that you're looking on. That's where I'd like to leave my demonstration for today. I'd like to pass it on to Jeremy again for some final words.
Great. We also have one more question. Can we show the coordinate grid and north arrow on the plan view? The answer to that is yes, you can. If you'd like us to show you how to do that, we can definitely set something up outside of this webinar to do that.
I can quickly show you the coordinate grid. Let me just do that. I'm just going to double click on my plan window. But the other thing, the north arrow is going to be a little bit tougher. I can show you that outside of the demonstration because I have to actually go search for a north arrow that's not part of my actual plan window, but you can't turn on another one that's part of the plan window if you want to. It's a little bit too much information, but you can take some of that. I can turn off the minor grids if I want to. Let me just go back in quickly, turn off the minor grids. So now we just have major grids. All right, north arrow, quickly turn on the one that's in here, but if you want a more robust north arrow, you can get one steal one from other software and bring it into our software if you want to. Thank you very much.
Great. We got one more question. How much does the software cost, Jack? Do you want to cover that?
Cover that, Jeremy.
Okay, great. So the software, we do have some pricing for it. I'd love to discuss it with anybody that's interested outside of this webinar. So go ahead and give me an email or give us a call. The details should be in the email that you would receive for the webinar. And I also want to challenge anybody that has a road design out there. If you'd like some help with it, we'd love to set up a web demo one-on-one where we can show you how easy the software is to design your own roads. And with that said, we'd like to thank everybody for joining us today and come back again next week or
the
week after for another webinar series. Thanks, everybody.
One of our enjoyable series. Thank you very much, folks. Bye.